Solving linear quadratic systems by graphing uses many techniques we've looked at before. Many of these equations that are given are either given in ways that we can easily convert into standard form or vertex form so that we can solve to get key points. Key points that I'm looking for quadratic equations are the solutions, so the x-intercepts, the y-intercept, and the vertex. So the y-intercept we can see in one of the forms, and then solutions and the vertex we can get both out of vertex form. So let's look at the first two equations, the first two examples. We'll call this number 1 and number 2. We see that number 1 has a couple of equations that we can see some points really easily. So y equals -5 is the linear. It doesn't have the squared value, so it's not the quadratic equation. And y equals -5 means that it only goes through -5 on the y-axis. So it's a horizontal line right here. And then negative x minus 2 squared plus 4, there's a lot of things I can tell by this quadratic equation in vertex form. I can see that for the quadratic equation, the vertex is +2 and 4. So let's do that in orange. +2 and 4 is the vertex for the quadratic equation. So +2, +4 right here. Erase that a little bit. That's the vertex. I can tell this negative means that it's going to be facing downward, and then if we set the equation in vertex form equal to 0, we'll be able to find the solutions. So -4 equals -x minus 2 squared. And before I can take the square root, I need to get rid of this negative sign in front of the parentheses. So +4 equals x minus 2 squared. And then if I take the square root of both sides, positive and -2 equal x minus 2. And to get x by itself, which will be the solutions, x equals 2 plus and minus 2, which means 2 plus 2 and 2 minus 2, which is 4 and 0, 0 are our solutions. So here and here. And we want to be really careful about when we are looking at graphing these quadratic equations, because it really depends on where we put our points on where our solutions will be. But what we can tell reasonably, so before we graph reasonable solutions, because our parabola will extend downward in this direction, we know reasonably there will be two solutions, here and here. And then I would say that the solutions would be at -1 and 5 based on the scale of the graph, and you can talk about what is the scale of each graph. And what does scale mean? So thinking about that. But reasonable solutions, right? And then I would say that, so -1 and 5 and probably 5 and 5 or 6 and 5 reasonably. But those reasonable solutions would be solutions to any system, right? And so solutions would be points of intersection. And there's only one of 3 cases that these systems that look like this, with parabolas and linear functions on the coordinate plane, or linear equations on the coordinate plane, depending on what you're given, or horizontal parabolas as well. There's only a few different cases that you can have that these lines and U-shaped graphs can intersect. And you could think about that. That's another question that you can ask yourself in your journal. So another question to ask yourself would be, what are the possible cases for solutions to these systems? And I would draw visuals as representations. So that will be something else I will look for in your notes. But yeah, so let's look at number 2, and I'll do just another quick kind of thinking about how we could go about solving these linear quadratic systems